Solve the inequality when the solution set is written in interval notation. What is the first interval in the solution? Notice the first interval is the one furthest to the left on the number line. If there's only one interval in the solution, you choose that one interval. X squared plus 7x is less than or equal to negative 12. You know, I think I have room to do this problem right here. I think I have room right there. To solve inequalities, we use the cut point method this semester. The first thing we do is we'd ask ourselves, when is the inequality equal to? So when is x squared plus 7x equal to negative 12? And we'd add 12 to both sides. And this factors very nicely to give us two different x values of negative 3 and negative 4. What sort of cut points were these numbers called? The ones that solved the equation that made the left side equal the right side. Solution cut points. So we have two solution cut points. First thing we do is we'd ask ourselves, when is the inequality equal to? Then we'd ask ourselves, when is the inequality undefined? What would we conclude there? What would we conclude? There are no denominators. These are polynomial expressions. They're always defined. What you're looking for in the second step are those denominators. You don't want the denominators to be 0. There are no denominators, so there are no denominator cut points. Third step.
Put the tap mark on, make your number line.
Okay, so I'm going to draw myself a number line. And remember, it goes small to big, negative 4 and negative 3. How are we going to label these solution cut points? These numbers make the left side equal the right side, and equality is acceptable, so I agree with the closed circles. We shade in those numbers. And notice in the factorization, we didn't get quantity squared. There were no even multiplicities. That's when you may have something like a false, false, true, or a true, true, false situation. Without those even multiplicities, I'm 100% certain that these are going to alternate, either true, false, true, or false, true, false. How do we decide? Test is okay. You can test any number you want to that's not a cut point, but the easy number to test is 0. Is 0 in interval 1, 2, or 3? 3, so I'm testing 0. Plugging in 0 into the inequality right here is where I'm plugging it in. I get a 0 plus 7 times 0 is less than negative 12. 0 is less than negative 12. True or false? False. So here, it would be true. And here, fifth and final step, we express our solution using interval notation. Bracket, negative 4. And notice, if there's only one interval, then choose that one solution. If there had been multiple intervals, we would have only chosen the interval to the left. But negative 4 to negative 3, that's the only interval. Response B. And number 9. I don't know if I have room for number 9 there. It's another cut point problem. Solve the inequality when the solution set is written in interval notation. What is the first interval in the solution? And so x plus 21 over x plus 2 is less than or equal to 5. Let me make sure I wrote this down correctly. X plus, yes. So y'all tell me, what's the first thing we do?
X plus 2?
No, before that.
You set it equal to?
Set it equal to. Okay, the first thing we do, we set it equal to. And then what did y'all say you wanted to do? Okay, so we're getting rid of the fraction. We're going to multiply through by both sides by that x plus 2. Realize that you can't do that to an inequality. You don't know if x plus 2 is positive or negative. Depending on the x value, it may be positive, it may be negative. Up here, you can't multiply by x plus 2 because if x plus 2 is positive, it stays a less than. If, say, x were negative 3, in that event it's negative, the inequality would have to be reversed. You can't multiply inequalities by variable expressions because you don't know whether they're positive or negative. You don't know whether to keep the inequality or change it. You have to set it equal to, and then I'll say multiply. That's going to give me an x plus 21 is equal to 5x plus 10, I agree. And I'd move the x term over to the right, combining it with the 5x, that gives me 4x equals, move the 10 over to the left, combine it with the 21. 21 minus 10 gives me an 11. So we're going to have a solution cut point of 11 over 4. And let me label that. That's my solution cut point. Will I have a denominator cut point? Yes. I do not want the denominator to be 0, so I do not want x to be negative 2. Next, I draw my number line and be sure to label these numbers from smallest to biggest. The two numbers I have to label are negative 2 and positive 11/4. Let's start with the denominator cut point. We don't have a denominator cut point in the previous problem, but denominator cut points, you never want x to equal that number, so how do you label it? Always open. It doesn't matter what the rest of the problem says. Denominator cut points, you never shade. Solution cut points, you look back at the original problem. Oh, where's the original problem? Right there. We want the left side of 11/4 makes the left side equal the right side. There's no little horizontal bar there saying equality is okay, so I agree with an open circle there as well. Oh, by the way, once again, notice when we're factoring, we got no even multiplicities, no quantity squared, so I'm 100% confident these are going to alternate. If I were out of time and I just had to guess, I'd either go true, false, true, or false, true, false. So one or the other, but how do I decide? Plug in 0. Which interval contains 0? Interval 1, 2, or 3? Okay, so if you got nothing else out of this course this semester, you can at least tell people that you know how to label, to find 0 on a real number line. Okay, that's what you got out of this course. You can spot the interval containing 0. So plugging in 0, we get a 0 plus 21 all over 0 plus 2, plugging in the, is less than 5.
False.
That's false. That's 10.5 is less than 5. That's false. So shade and
To the right of
and normally we'd write out, if this were my math lab and you were typing in your answer, you'd type it from negative infinity to negative 2, and what goes after the negative 2? I heard both. Which one? Parenthesis. You use a bracket when it's shaded. So parenthesis, union, parentheses. But remember, they're not giving you the entire answer. They're only giving you the interval. Here it is. They're only giving you the interval to the left. So the interval to the left, on the left-hand side of the number line, is negative infinity to negative 2. They are not writing out the entire answer for you. So you would choose response B. Any questions there? number 10. Oh, it's another inequality. Same instructions. X over x plus 1 is greater than or equal to 2. So what do I do first? Set it equal. So we have an x over x plus 1 is equal to 2. Okay, so we're getting rid of the fraction, multiplying by the denominator. And the x plus 1's cancel on the left. On the right, we have 2x plus 2. I think I'd move this 1x over, combine it with the 2x. I'd move the constant term to the left. What would that give me? X equals negative 2 for my solution cut point. So negative 2 is my solution cut point. Next. Okay, you don't want the denominator to be 0. I'm still numbering the steps, wasn't I? Okay, here's step 2. You don't want the denominator to be 0. X plus 1 can't equal 0, so x can't equal negative 1 for my denominator cut point. Next. Okay, I draw my number line. What goes first here? And negative 2, and then negative 1. One of these cut points is labeled open, one of them is shaded. Which one is open? Negative 1. You never want to shade in denominator cut points. Those numbers make the inequality undefined. You never want to include those in your solution. And negative 2, the solution cut point, makes the left side equal the right side. And notice, equality is acceptable. And next. Test. Okay, we're going to test.
0.
Interval 1, 2, or 3? 3. Testing 0. We have a 0 over 1 is greater than or equal to 2.
False.
False. That says 0 is bigger than 2. False. True. False. So my final answer.
Bracket -2, comma, -1.
Okay. And this was what, number 10? Negative 2 to negative 1, negative 2 to negative 1. Looks like response D. Any questions there? Number 11. Find the center and radius of the equation of the circle. No, find the center radius form. They've given us the center and radius. They want the center radius form. They're looking for the center radius form. So remember center radius form, it was x minus h quantity squared plus y minus k quantity squared equals the radius square. What number is acting like our h?
X. Oh no, wait, I'm sorry. -4.
No.
-6.
Negative 6. Remember the center is in the form h k. So negative 6 is acting like our h. Negative 4 is acting like our k. So we have h is negative 6. k is -4. What goes here? 3, the radius. And we can clean this up a little bit. Watch those double negatives. Remember, what you see inside the parentheses should be exactly the opposite of the signs in the center. So here, the center's x-coordinate is a -6, but minus a negative, you see a +6. The center's y-coordinate is -4, but inside the parentheses, you're going to see a +4. A, B, C, or D. Let's see. Which one? A, B, C, or D. X plus 6 squared plus y plus 4 squared equals 9. I agree with A. On number 12, the equation they give us for the circle is not in center radius form. Remember, center radius form is the desirable form for the equation of a circle. You can look at it, change sign, that gives you the center. Take the square root of that number on the right-hand side to give you the radius. That means, since you take the square root of this number to get the radius, this number had better have what sign? It better be positive. If it's a 0, then you just have a center point. If it's a negative, you have nothing. You have no graph whatsoever. But if it's a circle, that number on the right-hand side had better be positive. So here they've gone through, they've FOILed out the x parentheses, they FOILed out the y parentheses, they multiplied through by 3 and got it set equal to 0. You can no longer just look at the equation easily and tell the center and the radius. So the process, we'll have to go backwards and create those perfect square trinomials and factor them as binomials squared. That process of creating those perfect square trinomials, what's that called? Completing the square. Remember, our leading coefficients need to be what? A positive 1, but here we have a 3. What was our trick for getting rid to change it? Okay, so we're going to divide through by 3. That's the same thing as multiplying by 1/3. And then that's going to give me x squared plus y squared. That's a minus 4x plus 6y minus 3 is equal to 0 divided by 3 is 0. Then I would group the x terms together. X squared minus 4x plus, I'd skip some space, and then okay, and I move that constant term over. I agree with the equals 3. What number? Who remembers the steps we would go through to create the... Okay, and then you would do what? Square. Now realize that you're squaring the result, you're always going to be adding a positive number, so I'm not going to worry about that negative on the 4. Half of 4 is 2, and 2 squared is 4. So I'm going to add 4 to both sides. Repeat that process for the y's. What am I going to add in there beside the y squared plus 6y? 9. You said half of 6 is 3, and 3 squared is 9. I agree. So 9 plus 9. Half of 6 was 3. 3 squared gave me 9. Then these things factor pretty nicely. That's my little scratch work there. I'll mark that out. Let's factor the first trinomial as a quantity squared. How is x squared minus 4x plus 4 going to factor?
Minus 2 squared.
Okay. Remember, there's a pattern.
It's divide the negative 4 by 2.
Okay, so variable, sign, half of that number. Use that same pattern for the y's.
Y plus 3.
y plus half of 6, I agree, was 3. And
16.
we have a 16 over here, but in this case it doesn't really matter because all we're looking for is the center. So what's the center? 2, -3. Remember, change sign, change sign. So the center is at 2, -3. Number 12, 2, -3, 2, -3. That looks like response A. Okay, number 13. Where's that? Just shuffling through. Where's number 13? Where's number 13? Ah, here it is. Oh, it's another circle problem. Same type of problem, but in this case they want us to find the radius. Number 13. And I think I have room to do the work right out here, but I just prefer to, even though I don't really use the lines, I prefer writing on lined paper, even though you'll notice I don't use those lines that often. So here they're asking us to find the radius, but we still go through the same process that we did when we were trying to find the center. We got to get the equation in center radius form. There's only one correct first step. What is it? Divide by 2. I agree. We need the leading coefficients to be 1. The coefficient of x squared and y squared needs to be 1. That gives me a 1x squared plus 1y squared minus 12x plus an 18y plus a 108 equals 0 divided by 2 is 0. Now what do? Group the x terms together. That's an x squared minus 12x. Skip some space. Group the y terms. Y squared plus 18y plus, skip some space, equals negative 108. What am I going to add in there beside the x squared minus 12x? 36. Let's see if I agree with you. You said half of 12 is 6. 6 squared, I agree with 36. So add 36.
81.
81, let's see. Half of 18 is 9. 9 squared is 81. So I agree. Add 81. Add 81. So let's factor. Factor in the x terms as a binomial square. What am I going to get?
X minus 6 squared.
Okay, I agree. Variable, sine, half of that number. Now the y's.
5 plus 9 squared.
Okay, I agree.
225.
And wait a minute, it's a negative 108. A negative 108 plus a 117. Is that giving me a positive 9? Be careful. All we're looking for is the radius here, so the left side doesn't really matter, does it? No, so the radius, you take the square root of that number, and I agree with 3. And number 13, 3, that looks like response B, doesn't it? Let me write it there. After circles, we looked at ellipses and hyperbolas. Number 14. Number 14 says to graph the hyperbola and state the vertices of the hyperbola. You only have to graph as much of the hyperbola as is necessary to determine the vertices. I'm not going to draw the whole hyperbola. I'm going to go through the process until I'm certain of what the vertices are. And then I'm going to stop and answer the question. So We want to know the vertices. So, what should I do first? No, I don't need to get rid of the fraction. When I look there, I know the center. Remember, it has to go in the form xy, so the center, it's just like with any circle, you change sign. Okay. And then we determine that left-right movement and the up and down movement. Left-right movement.
The square root of 16.
Okay, left-right. X-axis is the one that runs left-right, so you take the square root of the x denominator, which is 4. Up and down. That's the y-axis. You take the square root of the y denominator, which is 3. And then I'm going to go ahead and start drawing it. But I'm only going to draw as much as I need to in order to get the center and in order to determine the vertices. So we're at negative 1, 2, right there. There's my center. We're going to go 4 units to the right. 1, 2, 3, 4. We'll go 4 units to the left. 1, 2, 3, 4. We're going to go 3 units up. 1, 2, 3. 3 units down. 1, 2, 3. And normally, if I were going to draw the hyperbola, I'd draw in my fundamental rectangle. I'd make the big X with those asymptotes, drawing in the diagonals. But I think at this point I can determine which of these points are my vertices.
It's going to be negative 1 and 4.
Negative 1 and 4. 1, 2. I think it's 5, isn't it? Negative 1, 5, that's at 2, 3, 4, 5. I think it's negative 1, 5, and down here, how did y'all decide on that? Remember, to decide on the vertices, you look at the variable that's in front of that connecting operation of subtraction, the first fraction. Which points did you get when you moved the square root of 9 units? We moved the square root of 9 units. Those were the up and down points. So the up and down points are my vertices. I could even sort of draw in the thing right there. One's going down, the other's going up. But the vertices are negative 1, 5 and negative 1, negative 1. And that would be response B. I agree, response B.
So whenever it's y first, though, that's kind of the rule of thumb, right? Whenever it's y first, they're always going to go up and down.
That's right. What happens if X is first? Number 15. The same type of problem. They want us to state the vertices. They want us to state the vertices. So, first of all, we need to know the center. 2, negative 4. I agree. Left-right movement from the center. The square root of 9 is 3. Up and down. The square root of 16 is 4. And I'll draw my XY grid. And let's see, the center is at 2, negative 4. So right 2 down 4. There's my center. I realize I'm just using the little lines as my grid marks. So we go 3 units to the right. 1, 2, 3. We were at 2. We move to the 3. So that's at 5. 3 units to the left. That's at -1. We went 4 up and 4 down right there. Which points are my vertices? Okay, realize the fraction in front of the minus sign, where is it? There it is. It was the x one. Which points did we get when we moved the square root of 9 units? They were the left-right points. So the left-right points, graph's going to go like that. Chelsea, you can make another generalization. You said if y is first, it's going to be up and down. What's the other generalization you can make? If x is first, it's going to be left and right. And what were these points? This was a 5, -4, and this one here, -1, -4. So my vertices were 5, -4, and -1, -4. 5, -4, and -1, -4. That looks like response what? C. And I think that's enough.